Okay. And so if you have a question, write it in the chat while we're going, and that way it'll be easier. And Janet should monitor the chat and kind of interrupt. That's what we'll do here. All right. All right, let's go to the chat. Oh, okay. So Maria asked in the chat already. She didn't know if the Globe Mission Earth was for everyone or for just experts who work with Mission Earth. It actually is for everybody. So I'll tell you what this is all about. So welcome to our first. Sorry.
So Kevin, you can see the chat room?
I can, but I have to open it up. So if you could.
Same here. I can't see the chat room, so I'll see it when we're done.
If you move your mouse, you should be able. It should pop up at the bottom.
Oh yeah.
All right. So yeah, welcome to our first webinar for the Globe Mission Earth. We're planning to have probably 6 webinars this fall, and the idea is to support Globe projects for well, for Globe. Let's see if I can change. Oh, I know I have to do a PowerPoint, right? There we go. All right, so what is Mission Earth? Actually, Mission Earth was a project funded by NASA, funded in January. We received the funding for fusing Globe with NASA assets, and the idea is to build systemic change in STEM education. Our partners are listed here, so we have the University of Toledo, of course, we're the head university, Boston University, WestEd, which is a group out of California, which also then links up with UC Berkeley, Tennessee State in Nashville, NASA Langley out of Hampton, Virginia, and then we also, the group out of WestEd, they're linked in with New Mexico schools, and we have a partnership with a New Jersey school. For tonight, these are the people who are going to be talking. Myself, so I'm a professor of the Department of Geography and Planning at the University of Toledo, and this is my 19th year. So I had brown hair when I started. Now I have gray hair. Jan Struble, who's the project manager for Mission Earth. Sara Mierzwiak is a graduate student, and she's done a lot of work on this. And then Laura Schetter is a Toledo Public School teacher, and she videotaped her students and her setting up a field site the other day. So she's actually not going to be with us today, but she's going to be here by video. And this is kind of the format we're going to use, kind of Globe 101. So we're going to start with defining your site today. If you are fairly new to Globe and you haven't defined a site on the Globe website, or you're just looking for new ways, maybe more efficient ways, this would be something that would be helpful for you. So each week or each time we do a webinar, we're going to have a similar structure to what we have here, kind of an introduction and some background information. Then we'll have a teacher feature, a NASA nugget, and tonight's NASA nugget is going to be what do you see, and then we're going to end with questions. And as I mentioned, you could post questions in the chat. So why are we doing this? Ultimately, our goal is to have students do research projects and then present their results. Educational research shows that if students do their own projects and they take ownership by developing their own research question, taking their own observations, analyzing their data, and then present it, they learn a ton by doing this. And in this picture on the right, that's my son, Timmy, presenting to, I think that's Dorian there, and Sherry Heron from, Sherry's from Mississippi, I think. So these are students on the left taking GPS and taking observations, and a student in the middle presenting her work, and then Timmy, of course, presenting his work. So there's opportunities through Globe to present, for students to present their work. So I wanted to highlight some of them. And this year, the virtual science fair, it's usually in early spring. So last year there were 115 projects submitted virtually to Globe. What was unique, I think, oh, it says 105 here, but I'll just say it's 115. Anyway. The neat thing was the students submitted their projects, and then scientists from the Globe International Science Network asked the students questions. They posted them on the webpage, and then the students responded to those questions before they, kind of received the judging. And then from those groups of students, there was a random drawing, and some students won funding to go to the annual meeting in Estes Park, Colorado this summer. There's also in the US, there are regional science fairs. In the Midwest, it's going to be at Purdue University. I'm not sure where the other ones are going to be around the country, so there's 5 regions. And here's some pictures from the regional science fair we had at the University of Toledo this past year. And then, of course, the annual meeting. And boy, if you can get your kids to the annual meeting, I think that it's very valuable. When I say kids, I actually mean my kids. So in this picture on the left, they're both in orange. Yeah, Timmy is on the right and Webby's on the left. All right. But then in this picture in the middle, actually, Janet, can you mute everybody so we don't get the feedback? So somehow we have feedback. Anyway, we have Robbie talking with students from Taiwan, Thailand, and Mongolia with NASA scientists and other people around the table. So that was pretty cool. So anyway, it was very valuable for my own kids, let alone kids. So Jan, is somebody, it's somehow feeding back and somebody's really loud. It might be you.
I'm doing it right now.
Actually, it might be you.
Oh.
Okay, so now we're going to switch over to Sara. Let me see if I can actually have to stop sharing. There you
go. Okay, I just unmuted myself. Okay, let me share my screen. Okay, I think we're good to go. So for those of you who were at our institute this summer, you'll remember some of this, but I took it and added a lot more information and expanded upon it. So this is my portion of the webinar today. It's locate a globe atmosphere study site using Google Earth and set it up in Globe. And the intent behind this is to teach you how to start with a geospatial technology like Google Earth to do an overview of your school grounds and look at and try to find a good globe atmosphere study site on your school grounds, and then how to collect the data needed to set that up on Globe. In this example, I'm using the University of Toledo campus, and then the same techniques here you can use for your own schools. So before I get to it, I just wanted to make a quick few notes about the Globe website. And this is a common, I don't want to call it misconception, but a misunderstanding maybe. So just in general terms, your school equals your organization. And to look at that, you log into Globe and click on My Page to see your member location and other info. And if you need to change that information, the best thing you can do is to get a hold of the Globe Community Help Team. And they have real responsive people there to give you a hand. Hold on. Okay. So with that being said, your organization can be thought of as an umbrella under which you establish a lot of different sites. You can have multiple atmosphere sites, hydrosphere sites, etc. And while in general these may all be on your school grounds, they don't necessarily have to be. So think of it more as a virtual umbrella. Another thing on the Globe website, we kind of recommend that you keep your own login, username, and password just for yourself, and then create under your organization a student login account. And you can do that by clicking right here where it says New Account, and then Create Student Account and fill this in. Just another real quick note too as well, if you click on this tab here called Collaboration, you access what's referred to as kind of like the social networking feature of Globe, and you can become friends with other people and see where those friends are located and make new connections. So I know that some teachers have really set up some interesting collaborations, having video conferences between classrooms, discussing data that their students have each collected. Okay, so getting right to starting with geospatial technologies is a great way to, first of all, right within the classroom, get your students to start thinking spatially, get everyone oriented about their school grounds before you actually go together as a group outside. The school that we visited, so Laura Schetter's school, which you'll see the video here shortly, we weren't actually able to download Google Earth, and then we tried to go to Google Maps and had we tried to go to Bing Maps, had trouble with that, and then ended up settling on Google Maps. So any of those would actually do for this. The advantage with Google Earth is it has some drawing tools, which I'll show you. And there's also ArcGIS Online, which we talked about during our institute, and there's more information available on that. If you'd like it, just let me know. So another hint, actually, in Bing Maps is really cool. If you use that, try switching it to bird's eye view. It's a very detailed aerial imagery option where you can rotate around from different directions and really help your students get an idea spatially of where they are. So the steps summarized as far as using Google Earth to locate Globe study sites, basically, if you haven't downloaded it, you go to the website, download it, open it up, and then zoom into your school, and then also zoom in further to a potential Globe atmosphere site in this case. Use the Add tool, and you establish what Google Earth refers to as a placemark, and then give it a title. If you right-click on that and select Properties, then you can see through the Google Earth the latitude and longitude of the approximate center of the site. And then you can use the ruler option to actually measure the site, make sure you're in meters, everything metric in Globe. And then I recommend that you record all this information, write it down, and then fill out the site definition sheet, which I'll show you some screenshots of. So again, if you start Google Earth, in this case, we're zooming into the University of Toledo as an example. And so looking at the campus from this point of view, the first thing you would do, looking at your own school grounds, is ask your students some questions. What do they see? They see parking lots, they see forest, they see green, grassy fields. So, and you can keep zooming in and out around these areas and talk about them with your students. And then try to talk as a class, what are the best potential locations for Globe study sites? So then start to narrow it down and choose. So for an atmosphere study site, you'd like a large, open, homogeneous area, such as a grassy field or an asphalt parking lot, both, even better. And it's best but not required that the area is at least 30 meters square, and 90 meters square is ideal for a surface temperature site. And you can plan for the future to place your rain gauge and instrument shelter in the middle of a large grassy field if you have it. So again, in this case, looking at the University of Toledo campus, the first thing that kind of pops out as a green grassy field is a glass bowl stadium. And we'll zoom in. And then using the toolbar at the top, add a place mark right in the center of the field. And you can see it pops up as a default untitled place mark. And then if you right-click on your place mark and select Properties, right away you get the latitude and longitude of that location. So then you can select the ruler option and measure the length and the width of the field. It's kind of hard to see there, but there's a yellow line going down the length. And that measured the length of the field at 110.59 meters. So then you take this information and head outside with some clipboards and start to fill this in on the site definition sheet. And you can find it through this link or just type in a Google search of site definition sheet globe.gov. You want to fill one of these out for each study site that you establish. I know this is kind of blurry, but what I wanted to show you here was that the site definition sheet covers all different types of sites, so from all the different spheres. And they're separated by these bold, dark lines here. So from here to here is your general atmosphere study site. From here to here is your surface temperature, here to here on down your hydrology. So this is only the first 2 pages, and this goes on for 6 pages showing all the different types of sites. So it's one form for everything. So go outside, start collecting that remaining site data. An interesting thing that you could do with your students once you have them outside with their GPS units and measuring the size of the areas, compare that to what you found in Google Earth and talk as a class. Are they the same? How much error did you get? And why did you think you have that error? So here's an example of the atmosphere site definition part of the form. And you can see these are the additional things that you need to look at to establish an atmosphere site. So are there obstacles on site? Describe them. Buildings. So in this case, you could put trees around the site, approximate heights. Let's see, other site data, the steepest slope. If you're going to have a thermometer established on site, what kind is it? And then your surface cover, is it bare ground, short grass, long grass, sand, etc.? Then you can add additional comments too. And then same thing here with establishing a surface temperature site. Sorry. Is it 90 meters square, 30 meters square, smaller than that? What cover type is it? And then for surface temperature, what kind of IRT instrument will you be using? Any comments? So once you have all that filled out in hard copy, which is what we recommend, and you make copies and keep those all the time, you log into your Globe account and go to data entry, which is right under Globe data. And then you choose this data entry desktop forms. And what pops up is something that looks like this, to where you can add a site underneath your organization. So you choose here. And then what you see next is this site definition. It's very similar to the hard copy sheet that you have. So you'll select here what kind of site, atmosphere, surface temperature. And then it basically just prompts you and leads you along the way. It doesn't show everything at once and is kind of a catch-all so that you don't enter erroneous information. So down here, there's a quick note I put in. Once your site is set up, have your students log in with their student account, and then they can begin to enter their data. This is something I wanted to throw in because it's buried in page 24 of the appendix of the implementation guide. And it's an incredible 2 pages worth of summary, master list of Globe protocols. This is just a screenshot of the atmosphere. And it's great because it shows you the recommended frequency, so you can see which protocols they recommend you do daily, clouds, aerosols, etc. Which ones you should do weekly, monthly, and then even seasonally. So what we're talking about here as far as setting up your site, and this once per site area right here. For more information, also check out page 21, and there's some written instructions here on your initial considerations for selecting your Globe study sites. Some very good information in there. And for even more information, see the Globe Teacher's Guide webpage, under which you'll find that appendix and everything else that you might need. And with that, I think I'll take some questions.
Does anybody have any questions? The quiet group. You're all muted.
Yeah,
I
maybe.
have a question. I just figured out how to unmute.
There you go.
I like the student site. Is that new?
A student login? I don't know. Is it Dr. C?
I'm going to guess maybe about 3 years old.
Okay. Thank you for showing us that. I did not know that was there.
I think what, Sarah, correct me if I'm wrong, it used to be that you could create up to 3 student accounts. I believe it's 10 now.
Yeah, you can create quite a few.
Yeah, so you kind of do it by class maybe. I only created 1, so it's like Toledo Student 1.
Right.
And I just give it to all the students.
This is Jim. I have a quick question. Last few days I've been like logging in going to globe.gov, and it's like it's missing all of the things along, like all the menu options. All it has is just your, like the news items, and then you can enter live data or view data. So am I going to the wrong place? Or it doesn't look like we used over the summer, or what you just showed us here.
Yeah, you might be in the low bandwidth version of the website.
Oh, okay. That's a problem because of my school then, huh?
Yeah, so when you initially log into the Globe website, you'll have something, if it detects that you have a slow internet connection, you'll have a pop-up window that says, do you wish to view the low bandwidth version of the website? And if you clicked on that the first time you went in, it will probably default to that every time you log in from that connection. Is that right, Dr. C?
Yes, yeah, that's I would say so. So I haven't run into low bandwidth at a school in quite a while.
So I wonder, do you know how I can fix that? Is there like a settings I can go to?
I'm not familiar. One thing you can do, James, is any question like this, send an email to help@globe.gov.
Okay.
And Roller or Eslam will help you, and they're really good, and they might be able to answer that question if you can go to a settings or something like that.
Okay.
Yeah, we actually had to use that low bandwidth version at Laura Schetter's school. So.
Yeah, I'm not sure why it went to that. I don't remember changing any settings, but that's how it's been appearing lately.
Have you tried logging in from home on your personal computer?
No, I don't think so.
Yeah, try that. And
Okay.
Okay. And then you can use that to send the help message, or you can always just call their hotline too. That might be the easiest.
Okay. I'll figure it out.
Okay.
Thanks.
Sarah?
Yeah.
Page 24 and 21, are you talking about the teacher's guide?
The appendix, the teacher's guide appendix.
Okay,
Yeah.
thank you.
Sure.
I have one question about the site setup.
Okay.
I still have to do the exact measurements, but my school is right in the middle of a neighborhood with huge trees and no green space, and our parking lot's small, and I'm really concerned about, is the data relevant if I end up going smaller than the 30 by 30?
Absolutely. Yeah.
Okay.
Dr. C, do you want to say a little more about that?
Yes. Yeah, so we published a paper on the snow and clouds, and several students have done their master's thesis using the surface temperature data. And what they do, when you do research at the university, they first clean the data up and look at it. So they'll look at the size of the site, but also they'll look at the location to make sure it makes sense, where the students say the point is versus where it probably is, if that makes any sense. Because there are a lot of latitude and longitude errors when setting up these sites. So, one of the biggest errors is instead of using decimal degrees, is using degrees, minutes, and seconds, which of course then puts your school in the wrong spot. So, if you list that I don't remember what school you're at, but say Jefferson High School, but your site shows up in the middle of Lake Erie, you know that something happened.
So,
Right.
Sean, was your concern mostly that you had tall trees that were kind of obscuring and, not a big enough open area?
Right. I mean, we pretty much go the school to a very small piece of green space to the sidewalk, and then we're at the street, and that's it. It's really, we're smack in the middle of a neighborhood. There's no playground areas, nothing like that there.
it all depends on also what protocols you're going to do. I suspect you're not going to put out a shelter with air temperature in it.
Right. No, no space for that.
Yeah. If you're doing clouds, you could actually use the Cloud app, the new Observer Cloud app, Globe Observer Cloud app, which you can do anywhere with your smartphone. You don't even have to set up a site for that.
I don't remember us talking about that.
Well, it rolled out on August 30th.
Oh.
So it's new.
Whoa. Okay.
I know we linked to it on our Facebook page.
I probably haven't been checking it much.
Okay.
Okay, I'll go check that out.
All right. And then, surface temperature, you could actually do the surface temperature of the sidewalk.
Okay. All right.
And just define that as your site.
Great. All right. Thank you.
You're welcome.
Do we have any other questions about site setup?
This is Jim. I have one more question. I was just thought of. After we come up with the site, are we required to do all of the testing that the protocols, like all the hydrology protocols, or can we just do some of them, I guess?
Yeah, absolutely. Choose what works for you. Start small. Keep adding them if you can, but don't feel like you're obligated to fill out everything. If you tried to do that, you would spend every day, all day.
Yeah. Okay. Okay. Sounds good. Thank you.
All right, Sarah, we should show the students at the Toledo School.
3, 2. Hi, I'm Sara Mierzwiak. I'm a PhD student at the University of Toledo, and I'm here today at the
Toledo Public School
Natural Science Technology Center Animal Science Program
of Career Technology.
And we are working to get this school into the GLOBE program. Today was the first day that we were doing some GLOBE work. And I'm here with 2 teachers, Natalie Cook and Laura Schetter.
And today we are defining our school's property by filling out information on a hydrology site and also atmosphere site with surface temperature. And so students today learn how to define our environmental site for the GLOBE program. Hello from the Natural Science Technology Center of Toledo Public Schools. This is the first day that we are implementing the GLOBE program here, and it is very relevant to the career technology world because students are learning about how they can analyze their environment and apply it to career technologies, how it relates to animal science and urban agriculture, landscape. So our students started today by analyzing our schoolyard to set up a site so that in the future we are all set to go to continue collecting data so the kids can learn about their local environment and eventually see how their local environment is connected to the entire planet through the GLOBE program. It's a pretty exciting day.
As Ms. Schetter stated, the students' goals for the day were to analyze their school grounds for possible GLOBE study sites and to collect field data needed to set up those sites on GLOBE. Following an introduction to GLOBE and its mission, Ms. Schetter emphasized to the young students that their field measurements would reach a global audience of citizens, students, and scientists. Ms. Schetter also told the students that around the world, there are other students just like them, collecting the same environmental data that they would be collecting on their own school grounds, and that future collaboration with those students was possible through the GLOBE program.
What I really want to emphasize is that GLOBE is a program, a school project that is used all over the world, at schools and by scientists. So what we are doing at our own school is a part of something much bigger. So I think it's pretty cool to think that what happens in our schoolyard, the environment of our schoolyard, is very, very important. And here's the thing, scientists are looking for data, for information about the environment. But scientists cannot be in every square mile of the world. It's impossible for them to get to every corner of the world. So that is why it's important for us to collect data about our schoolyard and share it with Globe, because then it becomes a part of an entire global system of information. What the environment is like in our school's backyard is a part of the entire global system. So it's important for us to look at what is happening in other parts.
After a class discussion, the students found 3 areas on their school grounds to focus on: an asphalt parking lot, a large grassy field, and a riffle area of a stream that runs through the campus. The students worked in groups and used a GPS unit to find the latitude and longitude of the centers of the asphalt and grassy areas, as well as the location of the stream study site. They then learned to calculate their stride lengths and paced off the lengths and widths of the asphalt and grassy areas in order to estimate their size. The students learned how to quickly estimate the heights of trees and buildings around their study sites as well. They did this by first measuring the height of one student with a measuring tape, and with that student standing against a tree, used their thumbs to estimate the total height of the tree. Here's a student's recollection of the steps taken to establish one of their school's study sites.
And today we learned about latitude, and we figured out the measurements of how far a field is and measure of how high a tree is by the height of myself. We also figured out how to find north and west from using our GPS and find out from our latitude from there too. Our main purpose of this are setting up data and collecting all types of data for our website. What we're going to is Globe, to help others in the world, in which they should be helping us too.
After just a short time performing each of these activities, the students' excitement and interest continued to grow. Now let's listen to some of the students on why they believe the GLOBE program is important and what they want to learn about throughout the school year.
Hi, I'm Brianna Griffin.
And I'm Kiana Griffin. We're students at Natural Science Technology Center.
I feel that it's important because it has to do with the climate changes and how it affects the animals now and the environment around us today.
Because it teaches us about our local environments and about places that we've never been before, and we get to learn about like their water system and how everything.
What I would like to continue learning is the soil. All about the soil. I want to get my hands dirty. Let's see if this soil is good for grazing for our animals, since I'm in the animal science care program. I want to know if this soil is fertile. Is it good? Is it bad soil? Is it good soil? What do we need to do to make this soil even better?
We would like to thank the Natural Science Technology Center, Ms. Laura Schetter, Ms. Natalie Cook, and Mr. Steve Oswanski for letting their students volunteer to be a part of this exciting first step in getting their school involved in GLOBE. We would also like to thank the administration of the Toledo Public Schools for continuing to welcome GLOBE with open arms into so many of its schools, and for believing in the importance of having students conduct local science investigations in order to help students and scientists around the world to better understand our shared global environment.
Saw shaking heads.
Everyone's on mute.
That's good. That's good. Well, that's good. That's nice, Sean.
Thanks, Diana. I saw your chat comment there.
So I want to spend a few minutes on some real, meaty stuff here. Our NASA nugget. So is everybody ready? Everybody says fasten your seatbelt. So this is some remote sensing stuff that ties in with, your site, or using Google Earth like Sarah was showing us. What does a satellite see? And this is the type of thing I use at the university at the beginning of the school year for my students. Let's see if I can move ahead. All right, there we go. So remote sensing is observing an object without touching it or being in contact with it. And so you have cameras and satellites, and you see the peeping Tom, I guess. I don't know what that is, but our eyes are remote sensing devices. And we're probably most familiar with the remote sensing devices at the hospital, x-rays, when my kids broke their arms and Robbie broke his forearm in half, and CAT scans of your brain and stuff like that. This is all remote sensing. And actually, Rochester Institute of Technology, they have their medical remote sensing and Earth remote sensing in one department, which is unique. So how does remote sensing work? Most remote sensing starts with the sun as the source of energy, and then that energy has to go through the atmosphere. The atmosphere affects the energy. And Jan, please interrupt me if there's comments that I should address, because I see comments coming up fast and furiously. So the atmosphere absorbs some of the energy. We know the ozone layer absorbs ultraviolet light. Water vapor absorbs some of the energy, and some is scattered by things like dust and clouds. Then it interacts with the surface. Some is reflected, some is absorbed. The energy comes through the atmosphere again, some is absorbed again or scattered, and then the sensor finally observes it. That data is sent to Earth and we analyze the data. So it's actually amazing that we get any information at all from these satellites with all that the energy goes through to get there. Of course, we're talking about the electromagnetic spectrum, and on here we have the visible light highlighted, so violet through red, and you see 0.4 micrometers is like the blue wavelengths, green in the middle, and then red about 0.7 micrometers. Something didn't show up there, but that's all right. Every object in the universe emits electromagnetic energy, even humans. So what I wanted everybody to do is to post, which one do you think is me, the one on the right or the left? So one picture is a thermal image of me, and the other is of Dr. Lindquist, who is a faculty member here. For some reason I can't see, there it is. Okay, everybody's guessing the right. I think it's pretty easy. But we see it in the thermal infrared, which is interesting. Thanks, Sarah. But Pete's a nice guy, so it was fun. We took pictures of the faculty and actually posted them online in thermal instead of visible wavelengths. All right. Oh, so here we go. This is what I thought I had on the last slide. So I put here some words. Hotter objects in the universe emit higher energy waves. Okay. Cooler objects emit lower energy waves. So, the gamma rays and X-rays, those are emitted by really hot stars. Is it oh gosh, now I'll say things that are incorrect scientifically, so please forgive me, but like pulsars or something like that. Something that's really hot. But then cooler objects emit lower energy waves. So the Earth is emitting in the thermal infrared. Our bodies are emitting the thermal infrared energy wavelengths because we are cooler, than the sun, for instance, and stars. The sun is in the middle of all these, emitting most of its energy in the visible wavelengths. And so we can utilize this, and this plays into our remote sensing a little bit. So our satellites are kind of broken up into two types. There's geostationary satellites and then low Earth orbiting satellites. So, okay, I'm going to ask another question. Let's see if I can bring up the chat. All right. So the other question is, what type of satellites are geostationary ones? What kind of information do we get from geostationary satellites?
Can you repeat
Weather. That? Okay, yeah, so geostationary satellites, these are ones that are above the Earth. They rotate once every about 24 hours. So they observe the Earth over one location. So we have weather and climate. And there's a big category that no one said yet of these geostationary satellites that some people use who live out in the country.
Vegetation?
Communication, yeah, some kind of communication. Well, cell phones, or satellite cell phones, and then also our cell phone information does get beamed to satellites, and of course then it goes around the Earth using these geostationary satellites. Wasn't thinking of that. Well, tablets, vegetation. No, there's something else here we're thinking of. In a rural area at my house, I can't get. TV, thank you, Tracy. Yeah, so you take your dish and you have to point it at a certain location in the sky, right? And that's the TV satellite, all right? But most of the satellites that we use are low Earth orbiting ones, and they're about 700 kilometers or a little higher. Okay, let's see. If I put a little TV, there's the things, TV, weather satellites. And so the low Earth orbiting ones are Earth observing plus GPS satellites. Now there's a cool interactive NASA site called ISAT, Interactive Satellite Tracker, and it has all the satellites, or okay, a lot of the satellites, where they are over the Earth all the time. Okay, it's kind of freaky. And then you can click on the satellite and see which kind it is, or what the name is. It has the GPS satellites, it has the Earth observing ones. I think it's a great way to show the kids, well, these are the satellites, we know where they are. It's a lot of fun. So I'd encourage you to go to this ISAT, Interactive Satellite Tracker website. Now, here's some meaty stuff. We're going to talk about the 4 resolutions of remote sensing. This is how we characterize satellite images and stuff like that. So we have the spatial resolution. This is how big the pixels are. Temporal resolution is how often we can observe a location. The spectral resolution is the wavelengths we're observing. The radiometric resolution has to do with the noise to signal ratio. Since spectral resolution and radiometric resolution are really kind of more difficult concepts, we're going to skip those for tonight. We'll just focus on the spatial and temporal resolutions. These things play off each other when we have an image. To how often, the pixel size influences how often you can see a location. So this is my house in Google Earth. And you can't get Google Earth images very often, and so they get imagery maybe once a year, maybe twice a year. You can see it's high resolution. So I'm not outside in the backyard or anything. So Google Earth, the imagery is about ½ meter spatial resolution, but generally you can look at a small area. The temporal resolution, like I said, is usually 1 or 2 images per year. Now, if we look at Landsat, of course, meaning observing the land, Landsat has a 30 meter by 30 meter spatial resolution. As Sara mentioned, that it's a typical globe study site area or size. Because we do tend to use a lot of Landsat to do land cover mapping. You can see the pixels here, what they look like in this image in the center when you zoom in. This is a little bit of the spectral information. Landsat has 7 spectral bands. Actually, Landsat 8 has 11 spectral bands. But let's go back. Let's stick with Landsat 5 and 7. Sorry, I haven't updated myself. But it has 7 spectral bands going from like blue, green, red, near infrared, mid-infrared, and thermal infrared. So then what you can do, we have our 7 bands. You can put these bands together in different combinations to see different images. So a true color image would be 3, 2, 1. 3 is red, 2 blue, green, 1 blue. And we call a true color image. A false color image might be 4, 3, 2. So we include the near infrared, which our eyes can't see, but the satellite does. And the near infrared shows vegetation very well, so the vegetation will show up as red. Red data is shown as red. All right, nope, sorry. Just go through that quickly. All right, so here's an image of Lucas County. This is just a raw image where it's a false color with the red being vegetation. And I overlaid here a shapefile in GIS showing the farm fields. So in this case, we were doing a farm study. We only wanted to look at the farm fields. The city itself is in the center, kind of have residential areas to see some of the roads radiating out. The airport is over on the left. There's another airport kind of in the center down a little bit. And Lake Erie is on the right. Things you can do with this, you can classify it. In this case, we classified urban and suburban. Water, the forest of oak openings is in green. And the agriculture, we made red. kind of see the area is dominated by agriculture, except for the city, the water. You know, anyway, there's a lot of agriculture. These white things are clouds, by the way, and then the cloud shadow messes things up too. You see how it's dark. So Landsat has a spatial resolution of 30 meters, but its temporal resolution is every 16 days. So it's better than the information you get from Google Earth in frequency. It's more frequent, but you're losing that spatial resolution. You don't see things as well. All right, lastly, I'm going to talk about the SMAP satellites, the soil moisture active passive. And I got this off the Globe website. So if you haven't, you know, this is a cool thing for kids to do, is to take soil moisture observations. You know, it takes a little can, you dig, put the can in the ground, get the dirt out. And then, though, you can compare your data directly to the SMAP satellite data on the Globe website. And in this case, you see how there's a swath over like the Great Lakes and kind of east. And there's greens. The legend shows the greens and blues are high moisture. And then if you go out west, that swath, it's all yellows, right? So there's not much moisture out west compared to the east. Of course, this summer we went out west for the Globe annual meeting, and I was telling people, they didn't really appreciate it. You know, it's dry out there. Just move to the east. There's lots of water. You know, why live somewhere where you can't get water? Just me. All right, so SMAP has a spatial resolution of 36 kilometers. It's huge, all right? But it's using the microwave wavelengths. So these are very long wavelengths. And your temporal resolution is daily or every other day. So you get frequent observations, but over a large area. All right, why is the spatial resolution of SMAP so low? All right, I'll tell you because it's getting late. Here we go. Back to our electromagnetic spectrum. High energy waves, they actually are short, small wavelengths. You know, they have small wavelengths. Cooler objects emit longer wavelengths and they're lower energy. So the microwave, you see how it's way out here in the longer wavelengths. It takes more energy striking the sensor of the low energy waves. It takes more of these photons striking the sensor to record the data than it does if you have high energy waves. You don't need as many photons. So in order to get that many photons striking it using these low energy microwaves, you need to observe a large area. Okay? If you use high energy waves, you can look at a small area and still get a good reading. I hope that makes sense. This ties back into the spatial resolution. And I just was having some fun. This summer, I worked with a teacher who was an English teacher. And, you know, he asked his big brother watching. So I was thinking of the literature 1984, which I actually read. It was a predictive thing, you know, before 1984. Of course, now it's in the past. She said actually that it's more relevant for the kids of the Hunger Games, so linking remote sensing to the Hunger Games and Big Brother watching, because everything is being observed during the Hunger Games. So anyway, this is kind of a fun thing. And, you know, just to think about, is Big Brother watching? You know, this is on Google Earth. My garage door is open. Should I call my wife, you know? Hey, can you close the garage door? Of course, this was not taken tonight, right? This was, you know, taken, they don't take images very often. There's some other things, kind of cameras, traffic cams are all the time on. Okay, I got a speeding ticket the other day from a traffic cam. I hate that. So anyway, I wanted to end with that. Maybe I should ask if there's any questions before we, yeah, we should go into questions and answers. So there's a lot of questions here. We have Jaja. A way to remember low energy long waves, high energy short waves. Okay.
That was from Mike.
Okay, does anybody have any questions? Doing a dramatic pause, right?
comment.
Okay.
Just real quick, I'm glad that you kind of emphasized that there are multiple sensors on satellites. I think that's a common misconception. People think one satellite, one sensor.
True. They're kind of like buses, or I don't know, Swiss Army knives. They have all kinds of sensors hanging off one satellite.
That's a good analogy.
Other thing, if you go on the ISAT, they have new things called CubeSats. So CubeSats are these little satellites that like universities are putting up that don't cost a whole lot. And the fact that they can track these CubeSats is pretty cool too. So Melody asked if it's going to be, all this will be on the Globe website. It'll be somewhere, and Janet will email everybody.
It will be on our YouTube channel. And you might not be able to find it because I just created it. But.
Yes, we created a YouTube channel today. So we'll put this video out there. We have a Mission Earth section on the Globe website. Not sure if we'll do that. But we'll get it out there so people can utilize it.
And like us on Facebook.
Oh yeah, that's a good idea.
And we'll also have the individual PowerPoints available as well.
So I'm such a great speaker, no one has any questions. I think, all right, well, we should wrap it up then.
You have to tell about our preview.
That's right, our next one. So our next webinar will be on September 28th. Same time, same place. And we're going to look at Lake Erie and harmful algal blooms. And of course, harmful algal blooms are happening all over the world. We'll do some review of the hydrology protocols. You know, we're not going to go into a lot of depth, but it could be a reminder for people. Melody's going to be our teacher feature. So thanks, Melody, for doing that. And then we'll have our NASA Nugget, most likely looking at GPM. So we're still working on some of the NASA details of what we're going to include. And our goal is to have some of the NASA people do the NASA Nugget. You know, I play a NASA scientist on TV, and I have this cool NASA meatball behind me on my drawer, but you know, I'm not a NASA scientist. I'm a university professor. And but we found out that most of the NASA people have young children. So 8 o'clock at night is not the best time for them to pop out. So we may have some videos of them as well. Let's see. Oh, okay. Now I have to. Oops. I have to share again to show the last thing.
So Maria likes we're talking about hydrology because that's the only thing they do.
Oh, okay. Great.
She posted that in the chat.
Thanks. So anyway, if you have any questions, you can email Janet. And then our webinar Facebook, we do have like this Facebook page. And then we will put it on YouTube. We'll get it out, hopefully, you know, just, it'll be somewhere you can find. We'll do it. All right. Let me just see if there's one last chat. All right, thanks, Maria. All right, everybody. I want to thank you for logging in and listening to us, and hopefully it was useful. Talk to you later.